Hello everyone, I am Ronnie, and welcome to the video. Today we're gonna be doing something a bit different. Today we will be talking about science. Now what specifically about science, you may ask? Well, my friend, today we will be looking at how to apply what we've learned so far this year in science in the real world. Now, this will include a brief summary about what was actually in the book and how do we use it. Now, a quick shout out to my other group members for all their fantastic work in putting this together. That would be Miss Czarina Kinkito. You know what? We're gonna go with that. Czarina Kinkito. Alonzo Lotas. Enoch Hwang. Mae Libre. And me. Now, you've heard enough about me talking about it. Let's just do this. First up, we have Chapter 1. Obviously, why would we start with anything else? Now, Chapter 1 served as a general introduction to the topic of Earth science. Now, the number one thing that you should have taken away from this chapter is the general discussion about Earth's spheres. Now, what are Earth's spheres? Well, Earth's spheres refers to a way of separating Earth's four main components into four general groups by which we can then subdivide into. Now, what are the four spheres? Number 1 is the hydrosphere, number 2 we have the atmosphere, number 3 we have the biosphere, and number 4 the geosphere. Now, the hydrosphere, by its root word hydro, refers to Earth's water. Now, obviously, the first and most prominent feature of the hydrosphere are oceans. They consist of 97% of Earth's water, and by themselves, cover nearly 71% of Earth's surface. Doesn't that make you feel tiny? Now, part 2, atmosphere. The atmosphere is the thin, tenuous blanket of air that hovers about 5.6 to 3.5 miles above Earth's surface. Why is this thing important? Well, have you ever tried to breathe? Good, because the atmosphere is what holds the oxygen by which all forms of life in one way or another need to live. Next, we have the biosphere. Yes, the biosphere, basically, it is life in general. Whether it be the plants that your grandmother killed in the garden this morning, the once-alive animals that we all had for breakfast, or the plants which we crush every day when we walk in the fields. These are in the biosphere, and basically, if it breathes, if it can change things without being dead, it's a part of the biosphere. Next, we have the geosphere, and if you can say something about the geosphere in 2 words, it's basically that it holds rocks. It's basically all the rocks that we can stand on. Yeah, the geosphere can be subdivided into its 3 main layers: the core at the center, the mantle in the middle way, and the crust, which we all get to see in our daily lives. Now, because of pressure and heat, the further down into the Earth's crust you get, the hotter it gets, and the more liquidy it gets. If you know what I mean. Yeah, I'm gonna move on from this. So, this is gonna be real quick, because you're gonna get real bored otherwise. Chapter 2 is all about minerals. It describes things such as how and why atoms, the small building blocks which hold every material thing together, bond together to create everything we see. That's about all. Chapter 3 was about rocks. Now, there are 3 types of rocks: igneous, sedimentary, and metamorphic. Igneous rocks are okay, I guess. They form when magma from the earth emerges and cools, and sedimentary rocks are kind of basic. I mean, they show up when eroded materials start compacting and stick together, but I mean, the only one you really care about is... here you go.
It was a little rock in the earth, then it was mixed in a fiery earth. Made some buddies on the way, then it cooled down here to stay. Metamorphic rocks, so many metamorphic rocks. Metamorphic rocks, so many metamorphic rocks.
In Chapter 8, we talked about earthquakes. Now, if for some reason you don't know what an earthquake is, it can be defined as natural geologic phenomena caused by sudden and rapid movement of a large volume of rock. If that was too technical for you, the earth goes shaky, shaky. Why do earthquakes happen, one might ask? Before we can answer that question, you need to have a bit of an understanding about the Earth's crust. According to the modern understanding of the crust, geologists divide the crust into sections called tectonic plates, rather than identifying the crust as a single unified body. Because these plates are free to move, as the mantle beneath the crust is not 100% solid, they tend to lean against each other, causing a lot of pressure. These areas where the plates rub against each other are called faults, or an area of stress in the earth where broken rocks slide past each other, causing a crack in the Earth's surface. Notice I said the word stress. Imagine the amount of pressure created when 10,000 miles of rock are pushed against each other. Eventually, the pressure needs to be released, as the two opposing forces cannot hold it in anymore. This dissemination causes what we know as earthquakes, in which waves shake the plates violently during the pressure release. The shaking motions are caused by the seismic waves, a form of elastic energy that causes vibrations in the material that transmit them. There are two types of seismic waves, namely body waves and surface waves. Body waves have two types. The primary waves are known as P waves, and the secondary waves are known as S waves. P waves are pull-push waves. They momentarily push and pull rocks in the directions the wave is traveling. They can travel in solid, liquid, or gas, since they resist a change in volume when compressed, and will elastically spring back once the force is removed. S waves, on the other hand, shake the particles at right angles to the directions of travel. Unlike P waves, they change the volume of the intervening material by alternately squeezing and stretching this. Due to this, S waves are unable to transmit through gases and liquids. Surface waves cause the ground and anything resting upon it to move. They move in an up and down motion and a side-to-side motion. They also retain their maximum amplitude longer than P and S waves, hence causing greater destruction. The results are catastrophic. Take, for instance, the 1960 Valdivia earthquake. With a 9.5 magnitude recording, the equivalent pressure was comparable to 1,000 atomic bombs going off at the same time. If your area is in risk of being affected by earthquakes, here are some things to do. 1. Secure items that could fall or move and cause injuries or damage, like bookshelves, mirrors, light fixtures, television, computers, and etc. 2. Store critical supplies like water, medication, and important documents. Number 3, plan how you will communicate with your family members by devising a family emergency communication plan. Now, if you are unlucky enough to get caught during an earthquake, remember a few things. Number 1, drop down onto your hands and knees and cover your head and neck to prevent yourself from falling debris. If you are in danger from falling objects and can move safely, crawl for additional cover under a sturdy desk or table. If no steady shelter is nearby, crawl away from windows and glass doors. If you are outdoors, if you have have a chance to get outside, get away from buildings, street lights, and utility wires.
What are you doing? You're getting yourself scared. Come on, let's go now. Come on.
Move to an open area which is free from falling debris. Don't hide under trees, lampposts, or anything that can fall over you.
To the open area, because that's what the book says!
No. Wow! No.
Moral of the story: don't screw with earthquakes. You will die.
Next!
Chapter 13, because we skipped like another 5 chapters for some reason. What's up with that, ma'am? Anyway, Chapter 13 was about oceanography, the study of the ocean. It's a field that requires a broad understanding of many disciplines, from biology and ecology to physics and chemistry, or to history and geology. Oceanography is also a discipline that demands both time in the lab and in the field. It is important to study because the world's oceans are critically important for sustaining life on Earth. Maintaining ecological balance in the world's ocean helps ensure we are keeping the world's carbon levels in check. A large percentage of the world's oxygen comes from the oceans. If ecological balance should get tipped in the wrong direction, it could be detrimental to sustaining life on Earth. Also, the oceans of the world are vast places whose resources are virtually untapped. There is so much we don't know. Literally, the cure for cancer or any other deadly disease could one day be found in the study of the ocean and its contents. We need to continue to study and research and maintain the oceans of the world to help improve and sustain life on Earth. Several thousand marine scientists are busy at work in the United States dealing with a wide array of important issues, from climate change, declining fisheries, and eroding coastlines, to the development of new drugs from marine resources, and the invention of new technologies to explore the sea. All of these fields are intertwined, and thus all oceanographers must have a keen understanding of biology, chemistry, geology, and physics to unravel the mysteries of the world ocean and to understand the processes within it. In Chapter 21, we began to look away from our own little planet and began studying the skies. This field of science is known as astronomy. Of all the fields of science, one can very rightly argue that astronomy has evolved the most. Being one of the earliest studies, the heavens above have given mankind some pretty interesting information over the years. Probably number one is the fact that we are tiny. Like, really tiny. Do you realize that scientists have discovered a black hole that's nearly 1,000,000 times larger than the friggin' sun? You probably could have lived your whole life without knowing that fact, I'm sorry. But, as humanity has, throughout history, seen itself as the focus of life, ancient astronomers had assumed that we were the center of the universe, and that the moon, sun, planets, and stars all revolved around us. This universe system, known as the Ptolemaic system, named after Claudius Ptolemy, was generally accepted for centuries. Around the Middle Ages, however, scientists such as Nicholas Copernicus and Galileo Galilei found some inconsistencies with this model when observing the night sky themselves. For instance, Mars would seem to rotate backwards. These discoveries eventually led to the gateway of modern astronomy, by which we now know that the Earth is a planet orbiting the Sun. Following these breakthroughs, the scientist Johann Kepler observed that the planets orbiting the Sun were following elliptical paths, rather than simple circles, and that the closer a planet got to the Sun, the faster it would travel. Since then, we've become so advanced that we've gone so as far as to send mankind into space. And that's pretty friggin' cool if you ask me. And here we are at the end of the video. I know, it's so sad. So in conclusion, we can see that science is an essential part of everyday life.
learning the truths of every part of our reality, whether the water of the oceans, the rocks below us, or the skies above. Science leads humanity to reaches beyond even what our eyes can see. It allows us to further our capabilities and will eventually change humanity as a whole. Whether we're a simple office worker, an important business executive, or any other type of person, we need to learn and apply science for the betterment of not just us, but all our Earth and beyond. Thank you. This video was made in partial fulfillment of Earth Science 11, presented by STEAM-O Group 4. Special thanks to the following members for their participation: Czarina Kinkito, Alonzo Lotas, Enoch Hwang, Mae Libre, Ronald Kollman. And thank you for watching. Goodbye.